Adding physical values of two tangible objects is easy as we have instruments to measure them. We measure lengths of objects with tapes and add them. We measure weights of objects with balance and add them, etc. But fraction is not a tangible object, nor its value is physical property that can be measured with instrument. It's a comparative concept. That's why we cannot add values of fractions by measuring them with instruments.
Even though value of fractions cannot be measured with some measuring instruments, still the values can be added.
Obtaining sum of like fractions is easier, but obtaining sum of unlike fractions is little tricky.
Obtaining sum of like fractions is easy. It's because the value of all parts in like fractions is same. The sum becomes m plus n times of common value of parts. But, obtaining sum of unlike fractions is little tricky. It's because values of all parts in unlike fractions are not same.
LCM is the means to overcome that hurdle. The problem of different values is solved by breaking different values into parts having common value. Once we break down different values into parts having common value, the sum become total times of that common value. LCM is the means to break down fractions having different value of their parts into smaller parts having same value, thereby facilitating addition.
Suppose we want to add these three fractions. Then, LCM is the smallest value that is common multiple of denominators of all the fractions that we want to add. It means denominators of all those fractions can be converted into that one common denominator by multiplying with some or the other number. And once denominators of all the fractions become same, means varying values of different fractions are broken into one common value form. Adding them will be a cakewalk. The challenge is that in doing so, that the value of involved fractions shouldn't change, otherwise our question will change too. To convert all unlike fractions that we want to add into like fractions, we check what should be multiplied into denominators of involved fractions to change them to common multiple.
What needs to be multiplied to denominator of a fraction? To make it that common multiple, we multiply the numerator of the fraction with that number too. While understanding equivalent fractions, we have seen that multiplying numerator and denominator of a fraction with same number doesn't change its value. Concluding, to add fractions of unlike value, we multiply them with numbers that can convert them to like form, but we don't affect their value. Once all unlike fractions are converted into like form, adding them becomes super easy.